This is the game that you and me will be making together in this video, and I will walk you through the entire process of picking the art, to publishing it, and everything in between, split into multiple steps. Along the way, I will show you various tricks and game programming patterns. The hardest thing about game development in C++ is by far starting, and it took me literally months. But you will have overcome this step in one day by the end of this video. So let's start. The first step is to learn the language. And if you already know C++, don't worry, I'll keep this point very brief. Basically, you can start with any tutorial because, trust me, they're all the same, and learn the basics like up to classes, templates and STL containers. After that, start making projects rather than learning advanced stuff. Complete challenges on Codewars or make console apps. You will learn more by doing stuff than learning advanced language features. If you want more details, check out my videos on this topic. If you are still a beginner, I recommend watching this video anyway, because it is made to give you the motivation that you need, and you will also get some nice tips related to more things than just programming along the way. Step 2. Game math. If you are not a math fan, don't worry, this step will also be brief. You just need to understand what a vector is. So a vector is just a point in 2D or 3D space. So for 2D, it has two components, x and y. It can describe many more things however besides a position, like a direction or a force. Now, adding two vectors looks like this. If you want to subtract, you can just flip the vector subtracted, and then perform normal addition. So let's say this is an enemy ship, and this is our ship. We want a vector pointing from the enemy to the player. So to do that, all you have to do is take the player's ship position, and subtract the enemy's ship position from it. Now this is the direction to the player. Usually, for directions, we normalize the vectors, and that just means we make the vector's length be size 1. We do that simply by dividing it by its length. The nice thing is now that if you want to make the enemy go towards the player, we just take its position and add the direction to it times the desired speed. To use these vectors in code, we will use a library called GLM. This vec2 is just a struct with two floats. And the nice thing about GLM is the fact that it has many overloads to make our life easy. We can create, for example, a vec4 from one vec2 and two floats. We'll see more about it when we start coding. Step 3. Designing the game. To keep things simple, this part is very important. So to learn about it, I recommend you to watch some videos from Game Maker's Toolkit on YouTube. This is where I learned how to design my own Steam game, and I think I did a nice job for my first game. I will mention, however, to choose a game that doesn't take long to make. For my game, I had to spend a lot of time at manually making levels, and you can avoid that by making a game with auto-generated levels. So to keep things simple, we will just make a simple shooter game in this video. Step 4. Choosing the art. The art for the game can be more important than the gameplay itself, because this is what the players will see for the first time. So this is why I hate it when indie devs try to make 3D games with a realistic art style. They simply don't have the budget for that. Go for a toon shader look instead. So I will go on itch.io to search for some art, and this is probably a good time to mention that in the description I have the link to the repo for this game, with many commits to keep things easy for you to follow. There you can also download all of the assets that I will be using, plus some extras for you to play around with. Okay, so I went for a pixel art style, and let me share a trick with you. I want to use these nice hues of purple and orange. These colors remind us of ripe fruit, that's why they look so nice together. Finally, make sure all of your art assets work well together. Step 5. Configuring the setup. So this part is by far both the hardest and the least interesting of all of these steps. I remember me spending days configuring a C++ library, and I want you to be able to make your game today, so trust me on this one. I want you to just use my setup and skip this step for now, so you can see some visible progress with making a game, and learn these details after. So go to the repo of this project and download the first commit. Then right click inside the folder and select Open with Visual Studio, and you are done for now. Select Space Game and press Ctrl plus F5 to run. If you ever get stuck configuring my stuff, I have created a special channel on my Discord dedicated to YouTube content related problems, so you can go and tag me there for help. If you want to learn more about this setup, check out this video, or this video about my 2D library. Plus, my 2D library also has a wiki on GitHub. And finally, we get to step 6, coding. This is not the last one, but it is probably the one that we are here for. For this step, I'll show you how to code a game in C++, and I will try to share with you as many good advices as possible, so it is useful for you even if you already know how to make a game in C++. So, inside the resources folder are all the things that the game will need. So go ahead and paste the resources that you have downloaded from GitHub here. Now let's start coding. If you go to Solution Explorer, inside src gameplay, you'll find gameplay.cpp. Here, we'll write the code for our game. We can see that there are three functions: init game, game logic, and close game. So a game works like this. We have a window and we display stuff to it. Inside an if-neat loop, we clear the screen and redraw it, taking into account the user's input. So, init game is called once in the beginning, and then game logic is called, let's say, 60 times a second, if the game runs at 60 frames per second. So this line here are just to clear the screen and other small bits that need to happen. This line will tell the GPU to start computing everything that we have just given to it to draw, and it just has to be called once at the end. And this line renders a rectangle. Now we can start coding. If you ever get stuck coding a project because you feel overwhelmed, just start working at it with the simplest thing that you think that could get you to the next step. It is useless to plan ahead too much if you don't know how to do that thing. So let's just start by drawing the spaceship. So we need to load the spaceship's texture first, and that is easy. We create a texture and inside in it, we load it. You have to use the resources_path macro to get you to the resources folder. Make sure you enter the correct path. Then, this parameter tells the GPU that we want to keep the texture pixelated. Now to render the texture, we just have to pass it here. I should also mention that this parameter is a vec4, and it specifies where to draw the object. It works like this. The first two floats are the coordinates in pixels, and they start from the top left corner of the screen. The last two floats are the size of the rectangle that we are drawing. You should be able to see your ship now. If not, recheck if you are loading your texture properly. Okay, let's move our spaceship next. We want to hold its position somewhere, so for that, I will create a struct with all of the gameplay related data. This makes it easy to pass it around, but most importantly, it will make it a lot easier to reset the game correctly. So inside here, we'll add the player's position. Make sure you provide default values. Now let's create an instance of the game data and pass the player's position here. I like to use regions to separate different parts of my game logic. Regions don't affect the code in any way, but they help us organize our code better. So to move, we'll use a vector. We can check if a key is held, like this, and if so, we can set the vector to the desired direction. Now we need to normalize this vector because if we move on a diagonal, it will actually be bigger. So normalization means dividing by its length, but what if the length is equal to 0? Well, dividing by 0 sets your computer on fire, so we first have to check if the vector is not 0 and then normalize. Then we add that direction to the player, multiplied by a speed and delta time. So what is delta time? Well, remember when I said that the game calls the updates function 60 times a second? Well, that number can vary actually. And if it runs faster, that also means that we add the movement more often, making the ship go faster. So delta time is the time of the last frame measured in seconds. And we have to multiply by it to make the movement constant. So in this case, we'll move to 100 pixels per second. Ctrl plus F5 to check if everything is working, and if you ever get stuck, you can check your code with the commits of this repo for each step. Okay, let's make the camera follow the player now. We need a background first though, so we can see the player moving. I found this space background generator on itch.io that I'll be using, link in the description. Don't forget to tick the tiled option, we will need that. So we already know how to load the texture. We will just display it at 00 for now, before drawing the player. The order matters. Now to follow the player, the renderer has a camera that we can manipulate. Fortunately, I have a follow method on it. You can mess with these parameters to get the desired artistic result. Now, I would like to make the background tile wherever the player is going. Let's create a new file. under src gameplay, add tilerenderer.cpp. Whenever you see this dialog, click X or cancel. Also, inside include game layer, add tilerenderer.age. So let's create this struct called tilerenderer. We will store the background size as a member here, and we will add a method called render. This method will take the renderer as a reference. And we will also need the texture, so we will also store that as a member for a reason that will become clear later. Let's create the method and paste here the old code for rendering the background. Create a tilerenderer instance, set its texture, and call its method, and always test if everything is working when we are doing refactorings. Now, to make the background appear wherever the player is, I will draw 9 instances of the background, and the middle one will always be where the player is. This is not a perfect implementation, but will do for this game. So getViewRect will give us the rectangle that the camera is looking at. So let's first draw the 9 background patches. Now we want to add the viewRect position, but divided by the background size. So whenever the player moves one background, all of the tiles will be shifted by 1. I'll increase the player speed to test it, and I will also change the camera zoom. It seems to be working fine. Okay, now I would want to add a nice parallax effect to the background. To do so, first I have to split the features into multiple backgrounds with transparency, but don't worry, you already have these textures in your resources if you downloaded that. Of course, I would like to see your versions on my Discord if you do them differently from mine. So, to implement parallax, I will have multiple tiled renderers. Let's first load all of the textures and render all of the backgrounds to see that everything is working as expected. Okay, now, inside tile renderer, I will add a member called parallax strength. Let's not forget to also set it. So this will work like this. We will take the current player position and multiply it with minus parallax strength. This value will be added to the rendering call to make the background move slower. You also have to subtract it here for this logic to work. Don't worry if you don't quite get how this works. It is just a small portion of this entire tutorial. Okay, now I would like the player to rotate to face the mouse. I'll first get the mouse position, and I will also create a vector pointing to the center of the screen. This is just the screen dimensions divided by 2. Now I will create a vector pointing from the spaceship towards the cursor. I'll normalize it, making sure the length is not 0, and if it is 0, I will just set it to an arbitrary direction. Now, how can we translate this normalized vector to a rotation? Well, we have a function for that called atan2. Just pass this angle here as degrees. Now it seems like it is going in the opposite direction, so let's add a minus here to fix that. And now it seems like it is offsetted by 90 degrees, so let's also fix that. That's what I like about graphics programming. You can sometimes just mess around to find the right values. Now the camera is kinda jittery, and usually you can fix that by changing the order you do your things. So you have camera movement, player drawing, and background drawing, and swapping those around will usually fix the jitter. This time, there is still one more problem that we'll fix later, but for now, just place the camera follow code under the movement and before the rendering. With the addition of the rotating player, you probably noticed that we are not rendering it in the center of the screen. And that is because the renderer renders things starting from the top left corner. So let's fix that. Nice. It is time we prepare for when we will be making enemies. Let's use this texture atlas to render our spaceship. So, all you need to do to render using a texture atlas is to specify the texture coordinates of the spaceship when rendering, and the library already has a tool for that. But texture atlases like this have a problem. Neighboring tiles can leak, leading to visual artifacts like this. To fix this, I have a special method that adds 1 pixel padding around each tile. So let's use it. It is called loadFromFile with pixel padding, and it takes this block size parameter, where you have to specify the size of one tile in pixels, and for this tile set, it is 128 pixels. For now, it only works for square sized items, but I'll improve it later. Now, to select an element, we need to create a texture atlas padding object. We now have to tell it how many elements there are, and the size of the full texture after padding. I will improve this API sometime in the future. Now to use it, all you have to do is add it here, and index the right element in the atlas. Oops, forgot to load the right texture. Try to display another ship as the one we had before to see that everything is working fine. Sometimes, while programming, you might need to fix bugs related to the libraries that you are using. That's why I strongly recommend keeping them linked to your project as code, not as precompiled libraries, so you can more easily debug and modify them. It is also the case here, because I found a bug in my library that caused the camera jitter. Go on the follow method, and hit F12 or Ctrl-click it to go to its definition. Then, inside gl2d.cpp, comment these two lines. Now, these are the values that I use for the follow function, and I apply it before rendering. With this in mind, everything should move smooth. Let's add bullets. We first need to load the texture atlas, and you already know how to do that. One bullet seems to be 500 pixels for this tileset. Let's now add two new files, bullet.h and bullet.cpp. For every bullet, we'll have a position and a direction for now, and a render method. Now let's add the bullet header file inside gamelayer.cpp, and add a vector of bullets inside game data. I'll once again create a new region where we'll be handling our bullets. If we click the mouse, we'll spawn a new bullet moving in the direction of the mouse. And finally, let's render all of the bullets. We also need to pass the textures to our renderer. We could also have kept them globally or passed them as members, but this data-oriented way that I'm showing here is the best. We don't own the bullet's texture inside the bullet, and for a more complex game, copying a texture or storing a texture reference inside an object can introduce hidden couplings that can cause bugs. Plus, having the method ask for all of the things that it needs, we can easily see what needs what. This is why I also designed my engine or my Steam game like this. So let's render a bullet here and test it. Okay, now let's add a method to move the bullets. Finally, let's make the bullets face the right direction by copying the rotating code that I use for the player. Now, we can't just spam entities like this in the game, because it will fill up and crash. So if a bullet is too far from the player, we need to delete it. Don't forget to call I and continue here. So we now need to test if this code works. For this, let's talk about another tip. It is extremely important to make tools to make your life easier when making a game. For example, for Midnight Arrow, I have my own map editor, and the best addition to it was adding a copy-paste feature and the option to quickly reload the level. Things like this don't only speed up development time, but also make your game better. Like, think about it. Would the levels of my game be as good as they are now if I couldn't reload the level on the go? Definitely not, because I wouldn't have tested them as much. So for this game, we will use imGUI to help us test stuff. imGUI is one of the best libraries out there. It makes it extremely easy to add windows with widgets, and it is already configured in this setup. Let's go to the bottom of the update function and type imGUI begin and imGUI end. This will create a new window for us. Let's print the bullets count here to test if they indeed despawn. These three simple lines will create this window that you can even drag out or dock, and imGUI has so many more widgets, but we'll see more later. For now, our bullets indeed despawn. Finally, we can start adding enemies. Let's add again some new files, enemy.cpp and enemy.h. An enemy will have a type because we will randomly index different textures from the atlas for variety. A position, a view direction, and of course, a render method. Now we have some logic for rendering the player, so let's reuse it. Most people would create a spaceship class here and use that with a render ship method, but I have a better approach. I will abstract this logic into a simple function and just ask for all of the data that I need. This is more flexible because I don't need a spaceship instance anymore to use it. And you can still use methods on Struct that behave like a spaceship by simply reusing this function. Just make sure everything works again after we refactor. Now we can once again create a vector of enemies. Don't forget to render it before the player. We usually want to render the player last so we can always be seen. Let's use ImGUI again. A button will just return true if it is pressed. How nice is that? Let's simply push back an enemy at the position of the player. Okay, now again, let's add an update method. Let's make the enemy move towards the player, but let's make him slowly change direction towards him by averaging the current move direction with the desired one. If the resulting vector is 0, that means that the two directions are opposite. So I will just turn the enemy 90 degrees, in that case with this formula. Don't forget to call this update function. Okay, now let's control how fast the enemy turns, and we also have to add the delta time here. I will add this turn speed as a member, and I will also add a speed member, and I also refactor the code a bit. Now let's randomize the enemy stats when we spam them. Now I want the enemies to be the grey ships, because the player is colored, and it is good game design to be easy for the player to tell which one is which. So for this, I'll use what is called a computed goto. I'll just save all of the wanted values into a vector, and I'll just index into it randomly. Now they all clump together, but that's not a bug. It is due to the fact that they all follow me, and they all are spammed from my position initially. While experimenting with the code, I found this. Instead of normalizing the direction, I will keep its size clumped to some limits, and this will make the paths of the enemies more elliptical. I also make the ship randomly turn up or down here by 90 degrees, instead of just up 90 degrees as it was before. Now, as we did with bullets, we need to despawn enemies that are too far away. Okay, time for shooting. I'll return true from this function if the enemies need to shoot. If the player is in front or almost in front of the enemy, it will shoot. Let's also add the bullet if the update returns true with the enemy's position and direction. I'll also add a shooting timer, so we don't spam a bullet every frame. Fire time is the timer, and fire time reset is how much we should wait until the next shoot. This number will be randomized for every enemy. Also, fire range specifies how in the range should the player be until the enemy shoots. Don't forget to set them when you spawn the enemies. Now, before we make the bullets kill you, we have to be able to reset the game. So this is quite easy. We'll make a function for this, and all we need to do is to reset the game data struct. Let's add an ImGUI button to test it. I don't like how the camera isn't reset, so let's also force it on the player by calling follow once with tight boundaries, and let's also call the reset game on init to make sure everything is configured the same every time. It's time we add a health bar. Now, UI is kinda difficult because we want our elements to look good no matter the screen resolution. Let me show you what I mean by that. I have a UI library that will help us. First, let's load the empty health bar texture and the health texture. Now we need to include GLUI. So, we want the UI to be drawn on top of all of the gameplay elements, so we will draw it last. We also want to reset our camera because we want the UI elements to be always drawn in the same place no matter where we move. To easily reset the camera, we can call renderer.pushCamera and renderer.popCamera. Now we'll create a blank scope with a frame. And the frame is just used to specify where we want the UI to be. You can also have frames inside frames. Now we create a box. The box is the UI element, and it is responsive, meaning it takes into account the screen's dimension, or rather, the current frame's dimension. So making UI elements is very declarative. We want it to start 65% from the left of the screen and 10% from the top of the screen. We want its width to be 30% of the screen's width and be 8 times smaller on Y. This will give us a box that can just be converted to a vec4 to specify the position and the size of the UI element to be drawn, and remember, that it is responsive. This library's main feature is easy menus in a similar style to ImGUI, but to keep this video simple, I added a menu to this game in my previous video. So also watch that video after this one if you want to see how to do that, and I challenge you to add a skin selector using it. Okay, getting back to our UI, let's add the full health bar on top. Now I'll add a health float in game data, and to keep things simple, it will go from 0 to 1. Now I can just multiply this box width with the health. Once again, I'll use ImGUI to add a health slider to help me test this. This works, but it doesn't look quite right. And that's because we are just squishing the texture. We want to also change where we sample it from, along with changing the size. So, to specify how we want to sample a texture, we use this vec4 parameter called texture chords, and these are its default values. It specifies the top left and bottom corner of the image. So we just need to take the bottom right corner and bring it to the left. Very nice. Now you can see why I left life be between 0 and 1. And finally, we can make the bullets work. We need to differentiate from bullets shot by the player and bullets shot by enemies. And for that, I'll just add a bool member here. Don't forget to set it correctly. Now I want to use a different texture for the enemies. To test if a bullet hits a ship, I will create this intersect bullet function, and it is very simple. I will just check if the distance from the bullet and the spaceship is smaller than the ship's size. This is a simple point circle collision actually. Now for all bullets shot by the player, let's delete that enemy to test that it works. Now let's add them some health, and also implement the bullet's intersection with the player, as well. If the player's life goes under 0, we reset the game, and I'll also make him regenerate his life. Be careful to remove bullets when they hit something, otherwise they will continuously damage the ship. And also here, be careful because you need to break from both loops. Finally, I made the bullets bigger. Now, the last gameplay feature is to make the enemies spawn randomly. I could just choose a random value inside a square, centered around the player, but that simply is not a uniform distribution with regards to the direction. I want the enemies to spawn at an equal chance at any direction from the player. So I will just take a vector and rotate it randomly to choose a point to spawn an enemy. First, I won't spawn more enemies if there are too many. I will also create a timer for the enemy spawning. Finally, let's take the code that we have used to spawn enemies and move it into a function. I will also randomly spawn more enemies from time to time. Okay, let's figure out this logic for choosing the spawn position. So I'll take a vector that is quite big and rotate it. This is how to rotate a vector, but don't worry about it. It uses some mess that I didn't explain, but if you had to figure out yourself how to rotate a vector, you could have just searched it online and found the answer. Now let's test it and tweak the values here to our liking. I'll also set the enemy's bullet speed to a random value here. And we also need to make it a member of the bullet struct. Don't forget to also set it when the enemy shoots. Step 7. Polishing the game. So polishing the game will make it feel good to the player, so it is important when you want to sell it. Polishes can include better buttons, camera shake, particles and so on. You should know however about the 80-20 rule. It takes 20% of time to make 80% of work. And that is true. So if you look at our game, it is kinda done. But if we were to spend time polishing it, it would take 5 times as much. This also happened with my Steam game. It took me a month to get to here, and another 3 years to finishing it. And they look the same. So prepare to have to spend more time than you originally intended if you want to release a game. Or don't commit to releasing it if you know you don't have that much time. So for this game, I'll only do some simple things. And the first one is to add shooting sound. I already have an audio library configured called Era Audio. First you need to go to src platform, glfw-main.cpp. This is where the entry point actually is. Here include Era Audio and uncomment this line. Now we can create a sound and load it. I already have a sound in the resources. Don't use MP3s, because they have a weird license and you can't sell your program if you are using MP3 sounds. So let's play this sound when we shoot. But wait, don't run the program just yet. Turn down your volume first, because you don't know how loud it's gonna be. I'll actually turn down the volume first. I'll also play this sound for the enemies, but because there are many and I don't want to spam this sound too much, I'll actually play it only if it is not playing already. Now I will do one final thing. For each bullet, I will draw it 5 times, starting from a darker color to a brighter color than the original. I think the result looks nice. Step 8 is preparing the game for release. Now there are multiple things that you should be doing here, besides what I'll show. For example, it is good to report errors in a log file, so players can report them back to you. It is also good to have a version number for your game displayed in the main menu and also in the log file, so you know where the bug occurred. You should also make sure all save files work with the new update. In my Steam game, I save data as the key value pair, and I also save the current version number in the file in case I will need it later. If you want to save data for your game, I have a video on this topic. For now, let's talk about what is the release, debug, and release with debug info build. The debug build is just the code that you wrote compiled. This compiles the fastest, and you can debug this code. The release with debug info build will compile slower, because it will also optimize your code. You can debug it, but it will be harder, because due to the optimizations, some of your code will be thrown away or reordered, making debugging harder. Finally, the release build is what you need to ship to your users. So remember when I said that configuring the project is horrible? I was not lying. I found a problem that somehow didn't manifest for Midnight Arrow, but it somehow appears here now, so yeah, sorry for that. Comment these lines, and also these lines, and not these lines here. This is to link statically with the runtime library, and it is important because without it, the players won't be able to play your game. Now click this drop down, Manage Configurations. Click the plus here and select x64 release. Make sure you select the right option. Now this actually is a release with debug info, so let's rename it accordingly. Then add another release build, but for this one, change its configuration to release. Now change this flag to on, and then delete this out folder to refresh the project. Control save on the CMake file, and then you can build your game. So this flag removes the console, and also changes the resources path macro to have a relative path. So now, to run your game, you have to copy the resources folder and paste it where your exe is. Finally, let's remove the imgui code, and also remove it from glfw main while setting this flag to true. Now compile, and to ship your game, you just need to add these two files to a zip file. Use zip because some people don't have tools to unpack RAR files. Let's also add an icon for our exe. An icon is 128 by 128 pixels. So I'll just put the player's ship in Photoshop to make it that resolution. Then you can search online for PNG to ICO to convert it to an ICO file. You should be able to open that ICO file in Visual Studio if you want. Now create a new text file and save it as app.rc. And for the love of God, please go to View and click Show File Extensions if you are a programmer, for God's sake. Now, inside this file, write this line. Don't worry about it. You can find this information online, and this is the name of your ICO file. Now both this file and the ICO file have to be in the same folder as the CMake file. Inside the CMake file, add the resources file like this, and you are done. Once you compile your project, you'll have the new icon. Step 9. Making the page for the game. I strongly recommend you to release the game on itch.io, because it will break a psychological barrier. You will suddenly see yourself as a game developer, rather than trying to be one, boosting your confidence. That being said, it is very important for your page to look good. Check out this tutorial by Chris Zukowski on how to make a Steam page, even if you want to use another platform. And the last tip, use images and GIFs, not text. People don't read the text you write there, so keep it brief and use paragraphs, colors, or even emojis to break it down. I will start by making the cover image for the game. I think it is needless to say that it is very important because it is the first thing people see. If you want to sell your game, you probably want to pay an artist to make it for you. For this game, I want to market it as learning how to make this game. On itch.io, the cover image dimension is 630 by 500 pixels. So I will start from a nice screenshot from the game. I will add a nice C++ logo with a text and an arrow. Use a simple and visible text font. I also use this orange color because it is the opposite of blue. Finally, I'll add some effects and also add a filter to increase the vibrance and saturation of your image. Now, to make the page on itch.io, it is simple. Click Create a new project. You'll have to fill some data about it, and then don't forget to click Save and click View Page. Here you can edit the visual aspect of the page. To add a GIF, record some footage of the game first. You can do that by pressing Windows plus Alt plus R, and then the same thing or close the game to close the recording. Then go to Easy GIF to convert your recording into a GIF. Don't forget to optimize your GIF, because if it is more than 4 MB, itch.io won't let you use it. Plus the page will load slow. This is my result, but you should spend more time on your page than I did. Also, don't forget to credit your art if you need to. And wait, very important, bonus step 1, learn marketing, and bonus step 2, don't get scammed. So to put it simply, without marketing, you don't have any chance selling your game. But don't worry, you can learn that. Chris Zukowski has some talks on YouTube about that, but basically, you have to somehow market your game on one or more social platforms. I marketed my Steam game on YouTube. Wait, I'm marketing it to you right now actually. And about scams. Once I released my Steam game, I received a lot of SaaS emails of people wanting to play my game on stream, requesting for keys or other offers. Now they are just scammers that want to sell those keys online. So be extra careful at such things, like things that are too good to be true, or when they pressure you, or when they demand 5 keys from you, or when they have weird excuses. So if you found this video useful, please share it with a friend that needs it, and maybe subscribe. It took me a lot of time to make. And don't forget that there is a part 2 out already, about how to make the menu for this game. So also check that out. See you there.